Hello classmates, today we will learn about the operation and maintenance of insulators in the context of outgoing feeder bay equipment. In this lesson, we need to master the role, classification, and electrical properties of insulators as well as the precautions for cleaning and replacing them after learning. You should be capable of performing simple cleaning and replacement of insulators at the same time. We must also, through studying the reasons for regularly cleaning insulators, cultivate our safety awareness. By watching how to replace insulators, we aim to develop a meticulous and rigorous professional consciousness. The key and difficult points of this lesson are the cleaning and replacement of insulators. Now let's learn the basic knowledge about insulators. Insulators are commonly known as insulating porcelain bottles. Insulators are used to suspend and support the overhead contact system and maintain electrical insulation between live parts and earthed bodies. After seeing the picture below, you must be very familiar with them. We can almost always see them on outdoor lines. Insulators are one of the widely used important components in the overhead contact system. Insulators are used to suspend and support the overhead contact system and maintain electrical insulation between live parts and earthed bodies. It is used to maintain the insulation between the overhead contact system and the ground or grounded structures, as well as the insulation between different sections of the contact system. Simultaneously, it serves as a mechanical connection, bearing significant mechanical loads. The performance of insulators greatly affects whether the overhead contact system can work normally. They are widely used in substations, distribution devices, transformers, various electrical appliances, and transmission lines. Insulators are generally made of porcelain, i.e., fired from clay with added quartz and feldspar, and their surface is coated with a smooth glaze. Since insulators bear the load of the overhead contact system and are often subjected to mechanical forces such as tension, compression, bending, torsion, and vibration, they are required to have a certain mechanical strength during manufacturing. Insulators can be divided into indoor type and outdoor type based on the installation location. Due to its working environmental conditions, outdoor insulators are designed with larger sheds to increase the leakage distance and block water flow, ensuring reliable operation under harsh weather conditions such as rain and fog. In environments with severe dust or harmful insulating gases, specially designed anti-fouling type insulators should be selected. Indoor type insulators have no shed structure on their surface, so they are only suitable for indoor electrical installations. Based on their application, they can be classified in power station insulators, electrical apparatus insulators, and line insulators. The electrical performance of an insulator is represented by its dry flashover voltage, wet flashover voltage, and puncture voltage. Dry flashover voltage refers to the lowest voltage applied to cause flashover along its surface when the insulator surface is clean and dry. Dry flashover voltage is mainly significant for indoor insulators. Wet flashover voltage refers to the lowest voltage applied to cause flashover along its surface when rain is falling at a 45-degree angle to the insulator surface. When flashover occurs on an insulator, it is only a discharge along the surface of the porcelain body. The porcelain body itself is not damaged. After the flashover disappears, the insulating performance can still recover. However, after a flashover occurs, its insulating performance will decrease somewhat, making it prone to flashover again. Puncture voltage refers to the lowest voltage at which the porcelain body of the insulator is broken down and damaged, losing its insulating function. The values of dry flashover, wet flashover, and puncture voltage depend on the working voltage. The higher the working voltage, the higher the required values for these parameters. The electrical properties of insulators are not immutable. As the service time increases, their insulating strength gradually declines. This phenomenon is called the aging of insulators. Therefore, during use, the voltage distribution across insulators should be measured at least once a year to check whether their insulating performance is normal. After knowing the basic knowledge of insulators, let's learn about the operation and maintenance of insulators. In actual production, the maintenance of insulators is mainly carried out through regular cleaning and regular replacement. In humid weather conditions, dirty insulators are prone to flashover discharge, so they must be cleaned to restore their original insulation level. In general areas, cleaning is done once a year. In polluted areas, cleaning is done twice a year, and one cleaning is performed before the fog season. Cleaning of insulators is mainly divided into three types. One is de-energized cleaning. After the line is de-energized, workers climb the pole and wipe with a cloth. If it cannot be wiped clean, a wet cloth or detergent can be used for scrubbing. If it still cannot be cleaned, then the insulator should be replaced or replaced with a composite insulator. Another type is live line cleaning, generally using an insulating rod equipped with a brusher tied with cotton gauze to wipe the insulators on the energized line. The electrical performance and effective length of the insulating rod used, and the distance between the person and the live parts, must comply with the regulations for the corresponding voltage level. Furthermore, operation must be performed under supervision. Another cleaning method is live line washing with water, which is divided into two methods: large water jet and small water jet. The water used for washing, the effective length of the operating rod, and the distance between the person and the live parts must also meet the requirements of industry regulations. During the maintenance of transmission lines, to ensure the insulating strength of insulators, besides cleaning, insulators are also replaced regularly. In many cases, they are replaced during a line outage. Next, please classmates watch a 3D animation of replacing an insulator. Alright, after watching, everyone can see that the replacement of insulators also requires integrating a professional attitude of rigor, diligence, and meticulousness into your work. Classmates, in this lesson, we learned about the role, classification, and electrical properties of insulators. Combined with the above knowledge points, we learned the ability to perform simple cleaning and replacement of insulators. I hope that through this study, everyone can further enhance their safety awareness and cultivate a rigorous, meticulous, and conscientious attitude during insulator replacement operations. Finally, please complete the following exercises. That's all the content of this lesson. Thank you, everyone.